Okay, class, this podcast has to do with assigning oxidation numbers. So you can just kind of see the title over here. And essentially all we're doing is wanting to assign the oxidation state to compounds, or to elements in a compound. So there's 6 rules here. They're printed on your goldenrod sheet. You don't have to memorize them. Just be familiar with them. We want to assign oxidation numbers so that in the upcoming days we can tell whether something's being oxidized or reduced, whether it's losing electrons or gaining electrons. So anyways, we need to know what the oxidation number is so we can compare it on the reaction side to the product side of our equation. So simply, all this means is, if we go over here, what we're going to do is we're going to assign oxidation numbers for the 3 elements in this compound. So we want an oxidation number for hydrogen, we want an oxidation number for sulfur, and we're going to need an oxidation number for oxygen. So kind of if we look over on the right-hand side, we see that hydrogen is a +1 when it's bonded to nonmetals. So S and O are both nonmetals, so H must be a +1. And real quick, I'm just going to put a +1 up here, and I have that twice, so really H contributes a +2 altogether. If we look over here, we see that sulfur is nowhere to be found. Alright, so we're going to skip to oxygen, and it says oxygen is usually a -2. So in this case, I'm going to put a -2 here. And because we have 3 oxygens, that really is a -6 altogether. Alright? So the last thing is, or really the first thing, the sum of the oxidation numbers equals 0 for a compound or element. So all these oxidation numbers have to add up to 0. So 2 plus x minus 6 equals 0, which means S in this case must be a +4. So we have just assigned the oxidation numbers of each of these elements in the compound. So we go to our next one. And we need an oxidation number for K, for Mn, and for O. And again, K, if we go over here, the first one, the oxidation number of an ion in an ionic compound is equal to the charge of the ion. So alkaline metals, alkaline earth metals, and a bing, bing, bing. So potassium is a +1. So it's in an ionic compound, so it has the charge we would expect it to have. Mn, it says nothing about. Same thing for oxygen, it's -2. There's 4 of them, so altogether it's a -8, which means in this case manganese must be a +7, because again their sum has to be 0. Alright, our next one is a little easier. It only has 2 elements, H and O. And this is hydrogen peroxide. Alright, so it's stuff that you put on cuts typically. So again, if we look over here, number 2 says hydrogen is a +1 when it's bonded to nonmetals. Oxygen is a nonmetal, so it must be a +1. So it is a +1, and there's 2 of them, so I'm just going to change that to a +2. So altogether this has to equal 0. And notice it says oxygen is usually a -2, so not always, it's usually a -2. When it's hydrogen peroxide, because there's 2 H's and 2 O's, they really have to have the same charge but opposites. So oxygen is a contributes a -2, but there's 2 of them, so each one is a -1. Okay? So oxygen is typically a -2, but when it's peroxide, it's a -1. Alright, our next one is potassium chlorate. So we have K's, we have Cl's, and we have O's. And K, we've already looked at above, it's a +1, O is a -2. So K is a +1, O is a -2, but there's 3 of them, so I'm just going to put -6. So in this case, chlorine must be a +5. However, here we have potassium chlorite. So again, we have K, Cl, and O. But now, potassium is still a +1, oxygen is still a -2. So if we put a +1 here, there's 2 oxygens, that's really a +4. So in this case, or I'm sorry, a -4. I'm just going to erase that. Alright, so oxygen is a -4, and then chlorine must be a +3 this time. So notice it is different. So for a lot of these, they aren't always the same thing. The trends, you need to know the things on the right, because these typically tell you what something will be. So hydrogen is a +1 with nonmetals, it's -1 with metals. Oxygen is usually a -2, and then we have our alkaline metals, alkaline earth metals, bing, bing, bing. And then halogens, notice group 7, or 17, are usually a -1. Okay, so our last one we're doing just for the sake of, it's an ion. So it applies to number 6. The sum of the oxidation numbers of a charged ion are the sum of the charge. So we have N, and we have O. N we don't know about, but O is usually -2. And because there's 3 of them, it's a -6. And because the charge is -1, instead of the sum of our oxidation numbers being 0, the sum of them is a -1. So in this case, N must be a +5, because 5 minus 6 equals -1. So nitrogen's oxidation number is a +5. So that is assigning oxidation numbers. It's pretty easy. You don't have to memorize stuff. Just know how to work it and apply it. And these rules are on your goldenrod sheet.